Other than I can tell you what their counter argument is going to be. So we have DNA from the neck, from the fingerprints, which was brilliant on the police officer's part in here. That is one thing that we weren't going to do. This just kind of happened. They're going to argue, well, Annie was the nurse, and it makes sense that her DNA would be on Sabrina because...
That makes sense that her DNA would be on her neck.
Don't try that.
Put their hands around.
Yeah. She was probably taking care of her, and maybe she had some skin cells fall off onto her neck.
On her neck.
But yeah, I agree. Highly unlikely. And that's what you're gonna, if you guys can find anything like false positives on DNA tests, like is it likely that if I'm just around somebody that I'm gonna leave a lot of DNA, my DNA, if I'm just kind of hanging around?
Depending how close it gets.
Exactly, you gotta have a direct transfer usually. I mean, we're constantly losing hair and skin cells, but the idea that that would just happen to be there on the neck when all the injections were given elsewhere, I'm not sure, where are insulin injections given?
Usually on the
Thigh or the stomach. So that, there you go, there's the argument right there. It's on the thigh or the stomach. It doesn't make sense, her fingerprints are on the neck, there's no reason for it to be on the neck.
Also, she shouldn't be touching her if it's sterile.
Yes, and then the other thing, like, she didn't check to see if she's alive, because I mean, obviously, if you're checking to see if someone's alive, you might touch her neck.
or the wrist.
Yeah, she clearly states she never did, she didn't know she did.
Checking with their alive is accurate.
Yes, yep, which isn't close to where these things are at, so you guys got a ton of good stuff already, I like it. Okay, let's see what the DNA crowd figured out here.
Okay, so the first two pictures are of the two fingerprints that we took from the neck. And then the picture on the far right is of Annie's DNA. And as you can tell that all the DNA is an exact match for Annie's. So when you are analyzing DNA, there's a 99.9% chance that the DNA is from Annie. But there's also a 0.1% chance that it's not Annie's because of human error. In any science test, there's a 0.1% chance that there's a chance that it's always wrong because of human error. That being the case, we're pretty certain that this is from Annie. This picture just shows the probability of it matching someone else's DNA, which is very slim to none. So in DNA, there's a section called STR, or a short tandem repeat, where it shows alleles that are easily recognizable. This picture is just showing where each of the different repeats show up on the DNA strand. The amyl is the sex chromosome. So when you're conceived, you receive one allele from your mom and one from your dad. It shows your sex, so females have an XX chromosome and males have XY. The DNA report shows that the murderer has an amyl of XX, making the murderer female. So the STR also shows other alleles that when tested show different numbers. The numbers come from 4 different colors that appear in the test and result in allele sizes found in the reports. Every person has their own unique allele sizes that never change. The odds of people having similar alleles are extremely slim to none. Not even twins have similar alleles. Each allele represents different traits and characteristics. After looking at the DNA found on the victim's neck from Annie, it is evident that they are from the same person. All of the alleles match up, as well as the sex. That's all.
Okay, so if you guys are on the jury, do you guys understand what's going on here?
Yep.
So there's repeated sections of DNA, I might just say that CAG, 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 for the letters CAG, CAG. And it'll do that maybe 12, 15, 20 times. Well, you get that on chromosomes from your mom and from your dad. And so you end up with 2 numbers for each of those locations on a chromosome called loci. Yeah, go ahead and put those numbers up there. So like the locus, and these are all numerical, alphanumerical coded ways for the genes. So like 11 and 16 means that one of the chromosomes has 11 repeats for that region, and the other one has 16. So if you guys watch any court case in the future, which a lot of times they'll appear, Casey Anthony is a great example of one that was on all summer, a couple summers ago. They pull things like this up where they have those allele frequencies, and that's all done by doing sequences of these specific regions. There's 13 regions that the FBI has determined are highly variable among people. And then each of those has a probability of happening. So like the top one having an 11, you know, maybe out of a population, they sampled only 200 people, which is kind of interesting, but it works. And this is how they figure these out, which is where some of that percent error comes from. There's like a maybe 1% chance or 3% chance. Some of them are like 22% chance that someone else has those exact same repeats. But then when you look at two chromosomes at the same time, hey, how many of you guys are taking statistics right now? All right. How do you determine the probability of multiple events happening at the same time? So let's say I flip a coin. I expect 50% heads, 50% tails. What's the chance if I flip the coin twice that it'll get heads? How do you figure that out?
You do 0.5 times 0.5.
Yep, you multiply 0.5 times 0.5, which is even lower, right? So the probability drops of those two happening at the same time. That's all this is here, except you do it over 13 different regions. And so your number drops astronomically low to the percent chance that someone else on this planet has that exact same combination. The probability is extremely low. Better chance of getting struck probably by lightning than it is having the same DNA code.
And being eaten by a shark.
Right, and eaten by a shark, maybe at the same time.
Yeah.
Being eaten by a shark and struck by lightning, this is not gonna happen. So, it's very hard for lawyers on defense to argue against this. Not impossible, they might try, but very difficult.